with the circles now. Why so many circles? All right, why can't I just have the lines going like that and just graph it, right? All right, so again, I want to just review with you guys. They go by increments of what around here in degrees? 15, and in radians, they go by pi over 12s, right? Pi over 12s, okay? So now we're actually going to start plotting points on here and not angles, all right? All points come in this form, and it's already up there, so you don't need to copy it down. R theta, okay? R theta, like XY on the rectangular grid you've been dealing with your whole life. On the polar grid, they come in what's called R theta. You guys know all about the theta. 2 days of practice. That's the angle, okay? Now there will be a number in for R, which means I used to call it radius length, but it's called the directed distance. This right here would usually be the origin for the rectangular grid you guys have been using in your life, but now it's called the pole. Okay, it's called the pole, and this is the distance from the pole. All right, and I know this is like, just minds are spinning right now, but I'm going to show you how easy it is right now. Okay, so first one is plot 3 comma pi over 4. What I think it's easier for you guys to do, find where pi over 4 is, please. Find where pi over 4 is and graph it for me right now. Graph pi over 4. Okay, if you guys remember, we know we go by pi over 12, so what would you multiply pi over 4 by to make it into pi over 12s? 3, so multiply top and bottom by 3. You're looking for 3 pi over 12. You're looking for 3 away. All right, 3 away, right? I always like to draw my rectangular. You don't have to, but I always like to draw my rectangular grid just to see where I am there. Okay, so we graph pi over 4. Let's see, 1, 2, 3. There it is right there, pi over 4. Beautiful. So go ahead and graph it just like you guys have done the last 2 days for me. Make sure you tell me which direction it's going now. Now let's talk about the R value 3. Because this is a point. It's going to be a point. It is going to be somewhere on your terminal side. That's the distance away from the pole, 3. This is why the circles are there. This is why the circles are there. Everyone ready? This would be a distance of 1, 2, 3. So you go 3 out now. That point right there, if you want to label it, is 3 pi over 4. That point right there, 3 pi over 4. Yes? So 1 is the pole. No, 0 is the pole. Do I need to go 1 more out? 1, 2, 3, right? I'm good, right, everybody? Okay. So everybody good? Questions? Go ahead. Questions? Okay, let's keep going here because there is one little slight change I'm going to make when I get to it. Buck 35, find it. Find it. I want to graph 135, but let's graph 135. Graph 135. So I know where 90 is. That's why I usually start. I know where 180 is. Let's see, 90, keep adding 15, 105, 120, 135. Got it. So 135 is going to be right here. I make the angle with the rotational arrow. And 2 tells me it's 2 units from the pole. 1, 2, right there. And there is 2, 135. No big deal, right? Everyone good? Because I don't want to, and I know it seems pretty easy, but there's a little change up next. Any questions? All right, what is different about the point I'm asking you to graph now? Negative R value. There's a big difference now. Okay, there's a big difference because think about it. If I ask you guys to graph 2, 3 versus negative 2, 3, those are in 2 different spots. Everyone agree? Okay, so everyone go ahead and graph 3 pi over 2 for me. Find out where 3 pi over 2 is on the polar graph. Go ahead, find 3 pi over 2, just like we did the last 2 days. Graph 3 pi over 2. What are you multiplying each of the top and bottom by? 6, yep. To make it a pi over 12, so 18 pi over 12. So go ahead, find out where that is on the polar graph before we start plotting the -3. Do not plot the point either, because it's not going to be where you think. And remember, it goes to 24 all the way around, so if you want to count backwards, it's up to you. Find out where 3 pi over 2 is. Don't plot the point, though. I'll do the wrong point, sure. 1, 2, 3. No. That would be +3. 3 pi over 2. Right? Because remember, you can't graph these the same. So what do I do instead? When the R value is negative, you put it on the opposite ray. You go on the opposite ray. Kind of works just like X and Y axis on the other side. When one's positive, when one's negative. So I don't want to put my point there. I want to do it on the opposite side. You still make your rotational arrow for me to show me that's 270, but now I'm going to go on the opposite ray and go 1, 2, 3. That's where it is right now. There's your point. -3, 3 pi over 2. So when R is negative, you place it on the opposite ray. You got it, Matt? Not a big deal, right? It's cake. It's cake, man. It's cake. How about you back there? It's -3. Yeah, it's R. If it's negative, you go, no. If it's negative, you just go on the opposite side of your angle, of your terminal side, right? Because look, 2, 3 and -2, 3, I wouldn't graph the same, right? But here's 2, 3, but think about it. It's kind of very similar. -2, 3, I'd go on the other side. Very similar to this. If it's negative, I go on the other side. Everyone all right? Okay, how about -1, negative pi over 4? Again, it's on the opposite ray when your R value is negative. So negative pi over 4, go ahead and find it. Let's see, multiply by 12. That's going to, not multiply by 12. Come on, get your act together. Multiply by, even Carter got that. So -3 pi over 4. And remember, you're going which direction now? Clockwise, right? Clockwise. So start counting clockwise. 1, 2, 3. So here's -3 pi over 4. Still graph the angle and show me the rotational direction. But what's your R value? Negative, so I don't want to graph it on this terminal side. All right, I'm going to go on the opposite ray. Are we okay on finding the opposite ray? Get a straight edge out if you need to and line it up. On the opposite, I can't even see up here. And it's 1, right? So I'm gonna say right there. How's that look? Is that opposite ray? Looks good, yeah. So that's -1, negative pi over 4. I'm almost done here. This is beautiful. But we haven't even got to the tough part. Okay, a little on your own. Can you plot both those points for me? Both those points, that would be great if you could. Can you plot both those points? 2 pi over 3. So that one should go on the terminal side. And then -2, 4 pi over 3. Plot both on the same polar grid. So pi over 3, let's see, pi over 3 times it by 4, 4 pi over 12. So this is going to be 1, 2, 3, 4. Calm it down, boss. Don't start giving away my secrets here. This guy. What are you guys finding out? They're opposite. No, Matt, remember. Okay, that is 4 pi over 3, but it's -2. So you can't plot it on the terminal side. You got to go to the opposite ray, which conveniently ends up being the one you first graphed. So you got to finish up here. Hopefully you're noticing it ends up being the same point. We all in agreement? It ends up being the same point. Because here's the tough part about today. We're all jacked up about that. Here's where I got to get you to before we end class today. I'm going to give you a point. You got to give me a new point that's the same one. Very similar to what we did here. Okay? There are tricks, though. There are tricks. Here they are right now, so we can jot these down. If you are given any point, how can I find a point? I don't got the arrow. How can I find a point that's equivalent to it, the same point? 2 ways. Everyone ready? I could. Ready? Let me do that again. I could add or subtract 360 to theta. Everyone agree? Add or subtract. So I'm going to put, I could do theta plus or minus 360. And I'd get that same point. Remember doing coterminal last couple days? Okay. The other way to get the same point, which is what we did here, we could make the R value negative, but now I wouldn't do 360. Anybody know what we did? If I make the R value negative, I was right here. How do I get back there? That's not 360 degrees. That's what? 180. So I could go theta, make the R value opposite, and add or subtract 180 from it. That's how I could find some equivalent points, which is what we're about to do here. Before we do that, are they always going to, do we always work in degrees in here? No, we could work in. So real quickly here, if we are in radians, I wouldn't want to do 360. Anybody remember the equivalent to 2 pi? Yep. Anybody remember the equivalent for 180? Pi. So if we are working in radians, I would have to add or subtract 2 pi or add or subtract pi. Okay? Yes, Austin, go ahead. You could, absolutely, yeah. Yep, you could. But then, remember, at the end, what do I need my answer still in, though? Radians. You start in radians. So is it a little bit more of a process? Sure, but you can do it if you're more comfortable doing it that way. All right, here we go. We only have 2, but They're beasts. Okay, so I got 7, 140. This is not multiple choice. Which one of these, and there could be more than one answer, I'm telling you there are. All right. Which one of these, same as 7, 140? Okay. Which one of these is the same as 7, 140? So let's go through what we just did. Everyone ready? So 7, 140 will be the same as, if I keep the R value the same, what do I add, subtract to 140 then? If I go all the way around, 360. So what I want to do is find what 140 plus 360 is, what 140 minus 360 is. All right, so what points are the same as 7, 140 if I go all the way around clockwise or all the way around counterclockwise? So what points are the same here? 7, 140 plus 360? Okay, that's... I'm looking at multiple answers here. I'll figure out which ones match at the end. You good? So 7 and 500. 7 and negative 220. Okay, these are all the same points if I graph 7, 140. Okay, so far I have what? 7. Okay. And all the rest of them, take a look, are negative, right? Okay, so ready? 7, 140. What if I made the R value negative? That doesn't mean it's going to go 360. It's going to go 180 now. Okay, so I'm going to do 140 plus or minus 180. So find all the different values. So negative 7 and 320. Hey, look at that one. And negative 7 and negative 40. Look at that one. Boom. So there's 3 up there that are all the same point. Worst comes to worst. Graph, 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 graph. See how many end up on the same point. Okay, because you guys feel pretty comfortable graphing those, I think, at this point now. All right, so if you wanted to graph all of them, graph them. Everyone all good? Because the hardest part's coming up when we're doing. This is easy. Degrees is no problem. All right, let's go radians. Okay, 2 negative 3 pi over 4. Worst comes to worst, you can graph all of them, see which end up at the same point. Okay, ready here? Because this is where we're finishing here. That's all I need your help with, is finishing here. All right, what if the 2 stayed positive? You add and subtract what? 360, aka 2 pi. Okay. Now, some of us are going to struggle with this because it's 2 pi and there's a 4 in that denominator, right? So I got 3 pi over 4 plus or minus 2 pi. Okay, how the heck do I do that? Ready? Let me just do a little. Let's do negative 3 pi plus 2. Negative 3 pi over 4 plus 2 pi. You can't add those together. Why not? We're almost hitting graduation here, some of you. Why can I not add those together? Don't have a common denominator, right? Don't have. What would you like the denominator to be here for the 2 pi? 4. So if it's 4, I got to multiply the top by 4, right? Which would turn this into what? 8 pi over 4. Okay, so go ahead. 8 pi over 4. And what's that turn into? 5 pi over 4. So you know one coordinate that's the same as 2 comma 5 pi over 4. Hey! Now subtract it. Because you got to add 360 and subtract 360, right? And go ahead, just plug a minus sign in there now instead. Plug a minus sign. That would be what? 2 comma negative, if that was a minus sign, negative 11 pi over 4. Is that a choice? Okay, so there you go. Not a choice. Are we okay there? All right, now you also know you can go with a negative r value. So let's get that original point. If the r value is negative, what do you add and subtract to your theta? Come on now, nap time's over. Let's go. Sorry. All right, because here's what I'll get tomorrow. Oh, I didn't finish. I don't know how to do this. All right. What do we add and subtract to that theta? Pi. You guys tell me now. What should I change? We changed 2 pi into 8 pi. So I could have a denominator of 4. What do you think I should add and subtract now? What's pi the same as with a denominator of 4? Because remember, I want it 4, right? But something that's equal to pi. 4. Because watch, reduce, what do you end up getting? Pi, right? Okay. See if you guys can find that. Add these two, subtract these two. So go ahead, add them. What do you end up getting? Pi over 4. And subtract them. What do you end up getting? Negative 7 pi over 4. Any one of those choices up there? Negative 2 pi over 4 up there. Positive pi over 4, though? That's not choice 3, right? 7. Yeah. No, I was talking. This isn't it. Because it was positive pi over 4, which is not the same. Okay. What's that? Correct. Okay. Anything else? So tomorrow the toughest part's going to be changing the 2 pi into something that has the same denominator. Remember, you just need something divided by 4 that gives you 2. So 8. Okay? Everyone all right? All right. God bless the people who weren't here. But at least it's on video.